Now let's look at these numbers. 1 over 3, 1 over 7, 2 over 11. Let's check these numbers. If I divide this, like I did before, 1 over 3, 3 in 1, 0, points, 3, 10, 3 in 10, 3, 3 times 3, 9, 9 from 10, 1. Again, I move the 1. By the time I continue, I'm going to have 0.333. And if you continue like this is what we refer to as unending decimal. At the end of the day, if I want to write it, I just write 0.3. This shows that this 3 repeats itself. It repeats itself. So it is unending decimal like that. Now let's look at 1 over 7 again. 7 in 1, 0 points. In 10, 1. It remains 3. 7 in 30, 4. What does that give me? 28. In 2. 28 in 30 from 32. 20. 7 in 32. 14. 16. That gives me 8. 4 now. 5. You know, if I should continue like this, it will just be repeating itself. 7 times 5, 35. From 40, 5. 7 from 50, that is 7. So if you look at this, it will continue like this. So I start again from 1 again, and it will continue like that. So which means that if after subtracting 7 from 50, I have 1, I have come back to the initial operation. So this one will repeat itself again. Now let's look at 2 over 11. 11 into 0. In 20, 1. 11 times 1, 11. 11 from 20, 9. 11 from 90, that's 8. 88 from 90, that is 2. Again, this is what I have. So it is good to write like this. So it will continue to repeat itself. So those are the kinds we have as unending decimals. You can see we don't have perfect conclusion. It will just continue like that. You know, when we have fractions, like this one now, we always depict it like this, 1 over 3. So it means that I'm going to divide it like this. So this is 1 over 3, 1 over 3, 1 over 3. But when I want to express it in decimal numbers, I don't have any conclusive way to put it. It will just continue like that. Just to continue like that. So this fraction is what you have now expressed as decimal. So when you have anything 0 point something, 0 point this, 0 point that, we refer to them as decimal fractions. So like this one now, I have 0.14. So all I just need to do is to put 1 point here, point here. So it will continue. It means that if I should continue, these numbers are repeating over and over and over again. So the same thing here, the same thing there. So the 3 is repeating itself. 1, 8. So if I should do this one, I should continue. I'm going to have 1, 8, 1, 8, 1, 8. So that is about unending decimals. But when you have unending decimals like this, you might like to convert them to their fraction, form. That is like this 0.3, I want to convert it to 1 over 3. This 142,857 to 1 over 7. 0.18 to 2 over 11. But take note, if you don't have this, it means it is not unending decimal or recurring decimal, please. If you don't have this on top, it means that is your final figure. You know, we can have 0.3, you can have 0.18. Let me give you an example. Let's say I have something like 9 over 50. 9 over 50. This 9 over 50, I have it to be equal to 1590. I put points. 1590. What does that give me? 1. 1 times 50. 50. 50 from 90, that is 40. I put 0 again after 40. I have 400. 50 in 400, that gives me 8. So you can see, there is a difference between this one and this one. Please take notes. You might have it conclusive here, and sometimes it is not ending. So take note, please. So don't confuse yourself. This one is different from this one. This one gives me this figure. This one gives me this figure. Please take notes. So, which means I can convert this one to this one. I can convert this one to this one. Likewise, this one too. This one here, please take note. That's point here. That's point here. That's point here. Now let's see how we can convert from this to the fraction. Now let's see how you can convert unending decimal to fraction. You can reason it from two perspectives. Look at this one, 0.18. I'm talking about unending decimal now, please. For this one now, you know, this one means 0.18, like that. Because I have 2 points here, what do? Because I have 2 here, please take notes. I multiply this one by 100. So if I multiply it by 100, I'm going to have 0.18 times 100. What does that give me? It's going to give me 18 points. So this one recalls again. You understand? I have whole number here, and this one remains the decimal that continues to recall. Now, since I have this, how do I now remove this one now? The one that recalls, that is recurring, is going to be this one minus this 0.18. So I'm going to have 100 times 0.18 recurring minus 0. You can see, please take notes. This 100 times 0.18 recurring means this minus this again, You know, this one, if I should write it again, I'm going to have 18.18. This is just illustration. But we don't want to go into all this stress. I stopped here by putting points at the top. So this one is out of it. Now, if I want to remove this part, look at what it will give me now. This one will now be equal to 18.18 minus 0.18. You can see. And this gives me 18. Now, look at this. This one is 100 minus 1 into 0.18. Does it make sense? And that gives me 99 times 0.18 over 2. You can see now. This one has given me this. So what does that imply? It means that 18 is equal to this one times 99. So look at what I mean. 18 is equal to 99 times 0.18 recurring. And this is what I want to work on. Please take notes. So it's going to give me, therefore, 0.18 recurring is equal to 18 over 99. And since what I want is the fraction, I will just work on this and conclude there. So what does that give me? 9 there, 9 here, 11. So you can see we have got number to the number that generated this. Please take note. I initially multiplied by 100 because this one is 2. Is on top of 2 numbers. So I have this. Afterwards, to eliminate this part, I subtracted it. But when you consider this, it is by multiplying with 99. So you see, factorizing gives me 99.this one. And this one is equal to 18. So you see, so I have 18 equal to 99 times this. At the end of the day, it gives me this. Let's look at another one. That is 1 over 7. Now look at this. Let's convert this one to fraction. Because we have 2 numbers that are being repeated, we need to multiply by 100. So let's go. So it means that 100 times 0.21. What does that give? It gives 21.21. You know, it continues to recur. This one. Now, let me now subtract this one from this whole number. From this number. So it's going to be 10 times 0.2 minus 0.21. You see, it's going to be 21.2 minus 0.21 recurring. So this will now give me 99 into, because by the time I factorize it, 0.21 will equal to 21. Because by the time I subtract that one, it's going to give me 21. Now this number, because this is what we are trying to express as fraction, I will have it outside like 0.21 will equal to 21 over 99. So 3 here, I have 7. 3 here is 33. So you can see how simple it is. Sometimes you might need to multiply by 1,000. Sometimes it might be by 10,000. Sometimes it might be just by 1, by 10. So you get your answer. Now let's look at another one. Let's look at this one now. 0.21. We want to convert it to the fractions. Since this is the only one that matters to us, we rather make it like this. 0.2 plus 0.01. We'll be able to deal with this alone. It will now make sense. So let's leave this one out of it. So we work on this one alone. So we are going to make it like this, 0.01. And this is just one figure that is being repeated. Let's multiply by 10. It will give us 0.1 1. You can see, since it is just 1 that is being repeated. Now, since I have this 0.11, let me subtract 0.01 recurring from it. So I'm going to have 10 times 0.01 minus 0.01 is going to give me 0.1 minus 0.01. You can see. So this one is now going to give me 9 into 0.01 will be equal to, if you look at this, by the time I subtract this one, I'm going to have 0.1. You can see. Now, since I have 0.1, it means that 0.01 will be equal to 0.1 over 9, which will be equal to 1 over 90. Therefore, 0.21 will be equal to 0.2 plus 0.01. And that will give me 0.2 plus 1 over 90. By the time you look at this, it's going to be equal to 2 over 10 plus 1 over 90. So this will be 18. This will be 18 plus 1 over 90. And that will give me 19 over 90. 19 over 90. So you can see, anytime you want to work on it, work on the one with this dot on top. But because this dot on top is one figure, that's why we multiply by 10. Sometimes it might be more than one, like this one. Like when I divided by, I think 7, you can see how many numbers it gave. So which means that like that one, I'm going to multiply by thousands, tens of thousands, before I can work on it like this. So you can see, at the end of the day, 0.21 recurring gives me 19 over 90. But when the 2 and 1 are the ones that continuously recur, it gave me 7 over 33. And look at the way I did it. For this one, I separated the 0.2 because it's not recurring before I added at the end. For this one, because the 2 is also recurring, I did the 2 together. Please take notes. Another way I like converting this decimal to fraction is by looking at it from the perspective of sum of geometric progression or sum of geometric series. Let me put it that way. When I look at it as geometric series, look at this one now. I have 0.18. It's giving me 0.18, 18, 18, 18, like that. So if I should express it in this unit, I'm going to have 18 over 100 plus 18 over 1,000, 10,000, sorry, plus 18 over 1 million, like that. So, you know the formula for the sum of geometric series. The first time here, A, is 18 over 100. R is equal to this one over this. So if you do that, it's going to be 18 over 10,000 divided by 18 over 100. And what does that give me? 18 over 10,000 times 100 over 18. 1. So 1 over 100. So you can see 1 over 100, that is R. And you know the sum to infinity, because if you look at it, it's to infinity. For geometric series, A over 1 minus R. A over 1 minus R. What is our A here? 18 over 100. What is our R? 1 over 100. 1 minus R, that is 99 over 100. So it's going to be 18 over 100 times 100 over 99. So 11. So this is another way you can look at it. If you have added sum of series, geometric series, so to infinity, when R is less than 1, so it's going to give you something like this. And this is the formula. Since all of this can be viewed as sum to infinity, that's what it will give you. Now, if you look at this one, 0.21, we are going to have 0.21, 21, 21, 21. In this instance, you can now see it's 21 over 100, 21 over 10,000, 21 over 1 million, plus, like that. So our A now is equal to 21 over 100. Our R now is 1 over 100. So you can see. And if I should apply this formula now, it will be equal to A 21 over 100 times, what is 1 minus r is 99 over 100 times 100 over 99. So I have this 21 over 99. 3 here is 7. 3 here is 33. So you can see how it goes. Very simple, very straightforward. Now let's look at the last one. Look at this one. I have 0.21 recurring, and that will be 0.2, or let's make it like this: 2 over 10 plus 1 over 100 plus 1 over 1000 plus 1 over 10,000 plus like that. So it's going to be equal to 2 over 10 plus all these other ones. So you can see, this is the one that is in geometric progression. This part alone. Because this is the only one that we put dot on top. So let me now undo this. So to handle now is this part. Is this part. So looking at it, hey, from this series is going to be equal to 1 over 100. R is equal to 1 over 10. 1 minus r is equal to 9 over 10. So this one now gives me, it means that 0.01, that's the part that is recorded, the record, is going to be 1 over 100 divided by 1 minus r, that is 9 over 10. So it's going to give me 1 over 100 times 10 over 9. And that gives me 1 over 90. This part alone. Therefore, 0.21 is going to give me 2 over 10 plus 1 over 90. And that gives me 10 in 90, 9 times 2, 18 plus 1. So at the end of the day, this gives me 19 over 90. So if you have already done geometric series before, you can easily apply this to get your answer. But if you have not, or if you don't understand this one, you can apply the initial formula. Now let's look at the operations of decimal numbers. Now, I can add, I can subtract, I can divide, I can multiply. If I want to add, there must be standard way of arrangement because of the points. Look at this one now. Add 3.25 plus 36.75. If I want to add this, I must make sure that the decimal points are, on top of each other directly, like this. If I want to add this one, I'm going to add it like this: 3.25, 36.75. Look at it now. Because if this, you must ensure that this point and this point, they are directly on top of each other. So by the time I added this one, 5 plus 5 is 0. I bring 1 here. 1 here, plus 2, 3, plus 7, 0. You can see now. For the point, I must put it immediately, just to show that it is here. Bring 1 here again. It makes this one 4. 4 plus 6, 10, 0. 1 here, I have 4. So you can see, that is the major thing about addition and subtraction. You have to put you have to make the points, face on top of one another. If it is subtraction, let's for ease, let's make it like this. I'm aware that calculator has made all these things simple, and that's why I wouldn't do much on it. But it's good at least to remind ourselves about the principle of handling this. I have arranged it in such a way that the points are on top of each other. So what do I do next? I just do the normal arithmetic. 5 in 5, 0. 2 in 7, 5. 3 in 6, 3, and 3. So that's the answer. You can see. Now, assuming I have something like this, you can see. The most important thing is just to make sure that you have the points here. Let the point, decimal point, be on top of one another. And since I have it like this, for ease, let me put 0 here now. You can see, since this one is 3 decimal places, it's good that I make this one 3 decimal places too. Same thing applies in addition, same thing applies in subtraction. So I put 0 here, just like the trailing 0. You understand? Now, 5 in 0, I bring 1 from this place. 5 in 10, 5. You know it remains 4 here. 5 in 4, 1 back here. 5 in 14, that gives me 9. You know I have 6 here. 2 in 6, 4. 3 in 6, 3. So you can see. You can see how it goes now. Now, if it is addition, how do I do it? This one will be 5 plus 0, 5. It will be the same arrangement. 5 plus 5 is 0, 10. So I bring 1 here. So this one is 7 plus 2 plus 1, 10. I put 0 here. Make sure that after getting to this place, you put points. 6 plus 3 is 9. The one I bring from here comes here now. And that gives me 10, 0. So I have 40. So 40.005. That's how you do it. Let's look at multiplication and division. Let's look at multiplication now. Let's assume, okay, I want to multiply 1.2 by 0.6. 1.2 by 0.6. If you look at this, it's the same thing as 12 over 10 times 6 over 10. Take note of this. 12 over 10 by 6 over 10. 6 times 12, 72. 10 times 10, 100. Straight. And at the end of the day, you notice what will give you 0.72. Straight. But sometimes, it might not go straight like that. But just understand the principle. What do? We make it like this, 1.2 times 0.6. So what? This 0, we put like this 0, 0. From this 6, 2, you start. 6 times 2, 12. 1. You know it remains 1. 6 times 1, 6. 7. What do we have? You write everything down. Everything, you write it. Including the zeros. Every zero, everything, you write it. Now you now count how many numbers are behind the decimal points. From this place, I have 1. From this place, I have 1. So by the time you count it 1, 2, you now put the point here. You can see 1, 2. You now put the point here. Let's look at another one now. Now look at this. 0.24 times 0.6. 0.24 times 0.6. What does that give me? I can say 24 over 100 times 6 over 10. By the time I multiply this, 6 times 4, 24. 6 times 2, 12, plus 2, 144. 10 times 100, 1,000. So by the time you look at it, you can see that this one is more than this by 1 0. So I'm going to have 0.144 straight. Now, if I want to do it directly, I'm going to make like 0.24 times 0.6. Like the other time, it's going to be, this one will be 0, 0, 0. 6 times 4, 24. So 6 times 2, 12. That will give me 4. Count it. 1, 2, 3. So this one is 1, 4, 4, 1. So I'm going to have 1, 2, 3 because this is 1, 2, 3. So you can see it's the same thing as this one. It's the same thing as this one. So sometimes you might not even have the 0 like this. Just count. Even if you don't have enough, add the 0 to make sure that it gives you the number the total number after the decimal points. Add the 0 to make sure it gives you the total number after the decimal points. So you must get it to be equal to the numbers here must be equal to the numbers after the decimal point. And what I'm trying to say is you might have whole numbers. You might have whole numbers too when you multiply like this. So take notes. Now let's undo this. 1.7 times 2.05. So I'm going to have something like this. 1.7, 2.05. 2 times 7, 14. So this one is 34. So this one gives me 0, 0. So 5 times 7, 5. That's 35. 5 times 1 plus that 3, 85. So you can see, I'm going to have 5, 8, 4, 3. Now, to determine the numbers behind the decimal point, I'm going to count 1, 2, 3. 1, 2, 3. So you can see. So that's the way to handle the multiplication. Now let's look at the division. The division is close to the division in fraction. Division in fraction. That is just the way it is. Now, let's look at division. Let's look at something like this. 0.8 divided by 0.64. You know, like we said before, it is going to be 8 over 10 divided by 64 over 100. And that will give you 8 over 10 times 100 over 4. That is 80 over 64. You know, 80 is 10, 8 here is 8. So by the time you do it, you continue 5, 4. And that gives me 1.24. You see? Or you can say 0.8 over 0.64 straight. 0.8 over 0.64. And you can see that for this one to give you any significance, you multiply by 100. So you multiply both by 100. So it's going to be 0.8 times 100 over 0.64 times 100. So what I meant was, for this one to become whole number, you multiply by 100. So since this one, you multiply by 100 for you to get whole number. This one, normally if you multiply by 10, you are giving you whole number. But since 100 is the bigger number, you multiply the denominator and numerator by 100. So you can see it gives us reasonable figure now. So we are going to have 80 over 64. And at the end of the day, this one is 1.25. It's going to give us 1.25. So you can see it gave us 1.25. So that's the way you handle the division. The division can still be, you know, recurring or unending, like we discovered the other time, but the same principle. Like if you have something like 0.21 divided by 0.8, you know, it's going to give you something like this: 0.21 over 0.8. And if you want to make this one whole number, you have to multiply it by 100. This one by 10. So what do? You multiply straight by 100. Let's see, 0.21 times 100 over 0.8 times 100. So this gives me 21 over 8. Okay. And if you want to work it further, make it like this: 2.1 over 8. And it will give you 8 into 0. In 21, you have 2. It remains 5. In 50, you have 7. It remains 4. In 40, you have 5. So you can see, just do it. Though with calculator, it is straightforward, but sometimes you might need to do it quickly. And it's good you understand the principle. So far, so good. We have explored the topic decimal numbers. And for every level, I believe we have dealt with everything that is necessary. In case you have any suggestion or, you know, insights on this topic, you can contact me through the channel in the description or through the comment section. And thank you so much. I appreciate your support. See you in the next video. If you have not subscribed, this is the point to remind you that it's good you subscribe so that every time our video drops, you'll be part of the first set of people that will know about it. Share, let others know about it. Comment, please, and then follow in other channels. Thank you very much.